Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for chemistry for the year 2020. This is the second part of the recording where we are going to be looking at the next 20 questions. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice the JAMB exam and modular quizzes for free. First question here: a few drops of concentrated hydrochloric acid are added to another 10 cm cube of a solution of pH 3.4. The pH of the resulting mixture is... Alright, so we know that the pH scale ranges from 0 to 14, where 7 is the neutral point. Okay, below 7 is acidic. Okay, a substance that has a pH below 7 is acidic. Now this solution that has a pH of 3.4 is, this value is below 7, meaning that that solution already is acidic. Now the thing with the pH scale is that the lesser the value is, the farther away from the 7, from the value of 7, the lesser it is, the more acidic that solution is. Now if you have a solution that has a pH of 3.4, it means that solution is acidic. If you are now adding an acid to it again, like this concentrated hydrochloric acid, it means that the solution will become more acidic. And when you have it to be more acidic, that means that the value of the pH is going to be even less than what, 3.4, because the lesser the more acidic. Remember that the lesser the more acidic, but the greater away from 7, the more alkalinic or the more alkaline or basic that substance is. But in this case, okay, adding this acid to that solution will make it more acidic, and it becomes more acidic. That means that its pH value will even drop below this, so it will be less than 3.4. Next question on mixture and separation techniques. Chromatography is used to separate components of mixture which differ in their rates of migration. Okay, in their rates of migration, we can use chromatography, for example, to find the constituent color in a given solution. Okay, so let's say we have a solution, a colored solution. Now we can use chromatography to determine what are the various color, okay, that we have in that solution by just using say like a chromatographic paper. Okay, now what happens is you see that over time those colors are going to migrate, okay, along the column of that paper. Okay, and they will be separated. So let's say the original solution can be black, for example, but by the time these colors begin to migrate along that column, you start seeing different colors like red, blue, green. So so that's, you can use that to identify what are the colors that make up that that solution. Okay, so basically it is based on the different rates of the different rates at which those constituents or components at which they migrate along that column. Next, the liquescent substances are also said to be hygroscopic. Okay, the liquescence is a phenomenon where a substance absorbs water or moisture when it is exposed to the atmosphere, and then it forms a solution with it. Okay, hygroscopy is a similar phenomenon. However, in the case of hygroscopy, the substance does not necessarily form a solution with that water that it absorbs. It just becomes moist, okay, or sticky. But some highly hygroscopic substance can eventually dissolve in that water to form a solution, and so they will be, in that case, we say they are deliquescent. Helium is used in observation of balloons because it is used because of its lightness and because it is non-combustible. Okay, it does not support combustion or burning. Okay, we have a question on stoichiometry. 32 grams of anhydrous copper 2 tetrahydrosulfate 6 dissolved in 1 dm cube of water generated 13.0 kilojoules of heat. The heat solution is... Okay, so 32 grams of copper tetrahydrosulfate or copper sulfate liberates 13.0 kilojoules of heat. Alright, the molar mass of copper tiosulfate is 160 gram. And how do we get 160 gram? That is by adding the atomic mass of copper, sulfur, and 4 of oxygen in this. Okay, so you have 160 gram. The next thing we are going to do is, let us find the number of moles of copper in this 32 grams of copper tiosulfate. Number of moles of copper tiosulfate or copper sulfate in 32 grams of copper sulfate. The number of mole is equal to the given mass over the molar mass. The given mass here is this 32 gram, okay, of this copper sulfate. Divide that by the molar mass, which is 160. So you have 32 divided by 160, and that is 0.2 moles. That means that 0.2 moles of this copper tiosulfate produce what? 13 kilojoules. To get the heat solution, okay, is to find the quantity of heat, okay, that is diluted by 1 mole of this solution here. Okay, now if 0.2 moles is equal to this, we say let 1 mole be equal to x kilojoules. Okay, if 0.2 moles liberated 13 kilojoules, then let's say 1 mole is going to liberate x kilojoules. So we are looking for x, so we are going to set up a ratio here. We say is 0, like looking at both, like the sides, okay, both sides of these equations here. So we are going to have 0.2 divided by 1 is equal to 13 divided by x. 0.2 over 1 equals 13 over x. Then when we cross multiply this, okay, use the denominator to multiply this and this to multiply this, we are going to have 0.2 times x. That's 0.2x equals 13 times 1, and that is 13. Tells us 13. To get the value of our x here, we then divide both sides by 0.2, and we divide 13 by 0.2, you get 65 kilojoules. Okay, that means that 1 mole of this copper tiosulfate, which is 160 gram, is going to liberate 65 kilojoules, and that will be the heat solution. Next, a gaseous metallic chloride, MCl, represented as MCl, consists 20.22% of M by mass. The formula for the chloride is, so here we have the atomic mass of M, of the element M, which is not identified here, as 27, and of chlorine as 35.5. So we have to find the formula for this compound. Alright, so to determine the empirical formula for the compound, we are going to look at, first, let's start with what we have from the question, the percentage composition. Now they give us the percentage composition of M in the substance as 20.22, but they did not give us for the chlorine. Okay, they said this is a metallic chloride containing a metal M and chlorine. They only give us the percentage of this one here as 20.22. They didn't give us the percentage of the chlorine. So how do you get the percentage of the chlorine? The total percentage for this substance as a whole is 100%. So if the percentage of M is 20.22, that is 20.22 out of the 100, then to get the percentage of this one, we just subtract this from that 100. Okay, so if you subtract 20.22 from 100, you'll be getting 79.78. you see that if you add these two together, you are going to get what? 100. Okay, so we have that. Now we have their percentage composition. The next thing we are going to do is the atomic mass. The atomic mass of M is 27, of chlorine is 35.5. We will now divide this percentage composition by the atomic mass. That is, we are going to say 20.27 divided by 27. Here we are getting is 0.75, and we say 79.78 divided by 35.5, and that will give 2.25. Now after dividing by the atomic mass, we now look at, of these two, which one is the smallest. Okay, which one is the smallest here? That is a 0.75. 0.75 is less than 2.25. So we are going to divide these values here again by 0.75. 0.5 divided by 0.75 will give us 1. 2.25 divided by 0.5 will give us 3. That means that 0.75 will give us 3. That means that the ratio of M and chlorine in that compound is what? 1 to 3. Okay, so the empirical formula, alright, for that chloride is going to be M, like say M1Cl3. Okay, and we can just write it as MCl3. So we have MCl3 as the formula of the chloride. Next, on electrochemistry, What quantity of electricity will liberate is 0.125 mole of oxygen during the electrolysis of dilute sodium chloride solution? Alright, in the electrolysis of brine, that is dilute sodium chloride solution, to liberate 1 mole of electricity, okay, we are going to need 4 Faraday. Okay, 4 Faraday of to liberate 1 mole of oxygen, rather 4 Faraday of electricity is required. Okay, so that is for 1 mole. So 1 mole will require 4 Faraday. Is 0.125 moles will require is 0.125 times that 4 Faraday. Okay, it's like saying is 0.125 mole is equal to is 0.125 times 1. Okay, like 1 mole, and 1 mole is what we require 4 Faraday. So this will be 0.125 times 4 Faraday. 0.125 times 4, that is 0.5 Faraday. Okay, now 1 Faraday of electricity is 96,500 coulomb. Is 0.5 Faraday of electricity is going to be equal to is 0.5 times 96,500, and that will give 48,250 coulombs. Okay, next, which of the following types of bonding does not involve the formation of new substances? That is the metallic bond. The metallic bond is an intermolecular bond, meaning that is the bond between molecules of the same substance. Okay, molecules of the same substance, and this bond does not lead to the creation of a new substance. Okay, it does not lead to the formation of a new substance. But covalent bond, coordinate covalent bond, electrovalent bond, they are interatomic bonds. Okay, that is bonds between atoms of the same or different substance, and that leads to the formation of a new substance. Okay, let's say the bond between sodium atom and chlorine now will lead to the production of sodium chloride. That's a completely different substance from sodium and chlorine. Next, organic chemistry. An organic compound that does not undergo a reaction with both hydrogen cyanide and hydroxylamine can be, that substance can be alkanon. Okay, so alkanols, they do not undergo reaction with hydrogen cyanide and hydroxylamine. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. The substance often used for vulcanization of rubber is sulfur. Sulfur is used in the vulcanization of rubber. Next, also on organic chemistry, the chlorinated alkane often used industrially to remove grease is the tetrachloromethane is used in laundry. Okay, the tetrachloromethane is used in laundry. It is also used in fire extinguisher as well. So they use it in laundry to remove grease stains. Next question on stoichiometry. What mass of water is produced when 8.0 gram of hydrogen reacts with excess oxygen? So here we are going to start first with the equation of reaction. So we have 2 moles of hydrogen reacting with oxygen, reacting 1 mole of oxygen to produce 2 mole of water. So here we see that 2 moles of hydrogen produce 2 moles of water. We look for what is the molar mass of 1 mole of hydrogen. 1 mole of hydrogen is going to be 2 times 1. How do you get 2 times 1 here? Okay, the atomic mass of hydrogen is 1. Okay, and we have 2 of it here. So this is 2 times 1. This is 2 grams per mole. That means 1 mole of hydrogen is what? 2 grams per mole. 2 moles of hydrogen will then be, and of course we have 2 moles here. 2 moles of it will now be 2 times 2 grams per mole, and that is 4 grams per mole. Okay, that's what we get for 2 moles of hydrogen. 1 mole of water is going to be equal to, in 1 mole of water we have 2 of hydrogen and 1 of oxygen. So this is going to be 2 times the atomic mass of hydrogen, which is 1, plus the atomic mass of oxygen, which is 16. 2 times 1 is 2, plus 16, that will be equal to 18 grams. This is for 1 mole of water. Now if 1 mole of water is 18 gram, then 2 moles of water is going to be 2 times 18 gram, and that is equal to 36 gram. Okay, so what that means is that 4 grams of hydrogen, that's 2 moles of hydrogen. We said 2 moles of hydrogen produce 2 moles of water, and that 2 moles is 4 grams. So 4 grams of hydrogen will produce 2 moles of water, which is 36 grams. That is 4 grams. If we now have 8 grams of hydrogen, what we have here is 4 grams of hydrogen producing 36 grams. If we now have 8 grams of hydrogen, that means we have like double of this hydrogen. So of course, double the hydrogen will produce double the water. Okay, that is 2 times of this will produce 2 times of this. So this 8 grams that I have here is 2 times of this hydrogen. Okay, 2 times of this hydrogen. So it will produce 2 times of the water. If you use 4 grams of hydrogen, you will get 36 grams of water. If you are now using 8 grams of hydrogen, you will get 2 times this 36, and that will be 72 grams of water. Next, proteins in acid solution undergo. A protein in an acidic medium is going to undergo hydrolysis. Okay, hydrolysis, which will break it down. Okay, which will break that protein down into the constituent amino acids, that is the amino acids in it. Next, also on organic chemistry, the general formula for the alkanals are, the general formula of the alkanals or the aldehydes is RCHO. RCHO. Okay, where the R is an alkyl group. The functional group is the carbonyl group, as we have in the alkanols or the ketones. So RCHO here is the general formula of the alkanals. Okay, ROH is of the alkanol. RCOOR, this should be like R prime, is of the alkanoates. So RCHO, that is the general formula for the alkanals or the aldehydes. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Next, when cathode rays are deflected onto the electrode of an electrometer, the instrument becomes, so cathode rays, they are negative, they are streams of electrons. Okay, streams of electrons, and electrons are negatively charged. So when you deflect them to the electrode of an electrometer, what will happen is that that instrument is going to acquire the negative charge, and so it will become negatively charged. That instrument will be charged by induction. It will become negatively charged. Next, on mixtures, when a solid substance disappears completely as a gas on heating, the substance is said to have undergone, that is what is regarded as sublimation. That is a direct phase change from solid to gas. Okay, so when certain solid substance like camphor, naphthalene, like dry ice, iodine crystals, when they are heated, okay, they vaporize into gas. Normally the trend is that a solid is supposed to melt into liquid and then into gas like vapor, but there are certain solids that they go directly from solid to gas. Okay, and that is that process is regarded as sublimation. We call it sublimation. The reverse of that process is deposition. Next, an electron can be added to a halogen atom to form a halide ion with. So halogens, they are the elements that are in the group 7 of the periodic table. They have 7 valence electrons. That is, they have 7 electrons in their outermost shell. Now when you add another electron to it, that means that their valence electron becomes what? Becomes 8 now. Okay, because one more has been added to it, so it becomes 8, and it can only accept one more. Okay, they can only accept one more to attain the octet structure. Next, aluminum hydroxide is used in the dyeing industry as a aluminum hydroxide is used in the dyeing industry as a mordant. Okay, as a mordant in dyeing and printing fabrics. The most important element on the earth's crust is oxygen. Is the most important element on the earth's crust. It is essential to plant life and animal life. Okay, for the animals it is a respiratory gas, okay, that they breathe in. For the plants, it is a constituent of the carbon dioxide which they require for photosynthesis. So, and oxygen again is the largest elemental constituent of the earth's crust, okay, in terms of its let's say its percentage composition. Alright, the last question here: to obtain pure carbon 2 oxide, okay, carbon monoxide, from its mixture with carbon 4 oxide, the mixture should be passed through conc sodium hydroxide. Okay, it should be bubbled through conc sodium hydroxide. So what will happen is the sodium hydroxide would absorb the carbon 4 oxide in that mixture of the carbon 4 oxide and carbon monoxide. Okay, so to separate this mixture here of carbon monoxide and carbon 4 oxide, we are going to bubble that mixture through concentrated concentrated sodium hydroxide. Okay, we'll bubble it through this solution, from which the carbon 4 oxide or carbon dioxide would be absorbed, leaving the carbon monoxide. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at ScholarFedu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.